Alright guys, so now we are going to talk about the section 3.6, topics in the theory of polynomials, part 1. And one of the things you will have to do is to divide polynomials. So when very different school to divide polynomial, as you can see in this example number 1, if you have a polynomial px and this polynomial p over x is divided by x minus k, well, you can divide the polynomial px by x minus k by using the synthetic division. And when you are using the synthetic division, you are using k divided the coefficient 4, 8, minus 2, and 1. I like to use, instead to use k, I like to use negative 2. And you will understand why in the next pages or so. But the difference when you are using minus k instead to use k is you will have to subtract along your calculation instead to add. So let's move on to the first step, which is the same than the step that you can see right here in this white rectangle. You are going to multiply then, first of all you are going to bring down the 4, and then you are going to multiply minus 2 by 4. You are going to plot this number right here, which is going to be, of course, minus 8. Oops. So let me write that minus 8. There we go. And then what you are going to do is you are going to subtract. Every time you are going to subtract. Because you're going to subtract, this minus right here is going to become a plus. And so 8 plus 8 is going to be equal to 16. Then you do it again. Minus 2 by 16 give you minus negative 32. And then you are going to subtract. Negative 32 is going to become plus 32. Plus 32 minus 3 equal 29. Last one, negative 2 by 29 and negative 58. But you are going to subtract, so negative 58 becomes plus 58. With the 1, it gives you 59. So as you can see, I got exactly the same answer. The only difference is if I have a plus 2, I need to add. If I have a negative 2, I need to subtract. Now, once you are done with the expression of your synthetic division, you need to rewrite the answer. And so the answer is going to be what was cubed, now it becomes x squared. So this is why now we're having right here 4x squared. Then we are going to have plus 16x plus 29. And 59 is going to be the rest. And so obviously, if 59 is the rest, it's going to be 59 over x minus 2. Now, don't forget to look at the remainder theorem. And the remainder theorem is stating that the remainder obtained when dividing the polynomial function by x minus k is equal to p of k. So when the question is calculate p of 3, okay, basically you could simply divide negative 3 divide by negative 3 using the synthetic division 4 minus 9, then 0, because there is no x, so it could be 0, and then 7. Don't forget, you need to have a decreasing exponent in x, so you are missing the 0x. So you're going to have a 0 right here, and then you're going to do exactly the same thing. You are going to pull down the 4, negative 3 by 4, negative 12, and you are going to subtract, and so you're going to have plus 12, negative 9, minus 9 is going to give you 3. Minus 3, negative 3 by 3, negative 9. You subtract, so that's going to be plus 9. And negative 3 by 9 give you negative 27. You subtracting, and when you add both, you end up to have 34. So that is telling you that P of 3 is equal to 34. P of 3 is equal to 34. Well, you know what? Let's try to substitute 3 inside the expression of P of x. So if I want to calculate P of 3, the other possibility is to know, you know what? I'm going to do 4 times 3 cubed minus 9 times 3 squared plus 7. P of 3 is going to be equal to 4 times 27 minus 81 plus 7. 4 times 27, how much is that? 4 by 7 is 28. I take 2. 4 by 2, 8. And 2, 10. 108 minus 81 plus 7. 108 minus 81, it's going to be 19 plus 8. So it's going to be 27 plus 7. And up to have 34. That's another way to calculate P of 3. Okay, so let's try to define if negative 2 is a zero of P of x. First of all, let me tell you why we need to do this calculation. Well, take a look. If negative 2 is a 0, what does that mean? That means that P of x can be defined as a x minus negative 2 times another parenthesis. Why am I able to say that? Because if P of x, if negative 2 is a 0, that means ultimately I want to transform my polynomial degree 3 into 3 parentheses, because each of these parentheses, if I want to find the 0 of this polynomial, are going to be equal to 0. And if each of these parentheses are going to be equal to 0, each of these parentheses are going to give me a 0 of my polynomial. So, in a sense, if I have negative 2 as a 0, I should be able to write at some point P of x equal x plus 2 times another parenthesis times another parenthesis. So when I'm dividing my polynomial, and let's try to be consistent, because my polynomial is going to be divided by x plus 2. What I want to do when I'm going to do my synthetic division is I'm going to do is a 2. I'm taking plus 2 because it's divided by x plus 2, so I'm going to take x plus 2, I'm going to take 2, and I'm going to write my coefficient 5, negative 6, negative 28, 5, negative 6, negative 28, and the last one is plus 8. Plus 8. Alright, and I'm going to apply what I know, which is I'm bringing down the 5, 2 by 5 equals 10, but like I told you, that's the beauty of it, is now I know I need to subtract. That's it. I always subtract. But I need to do every time is subtracting. So 10 becomes negative 10. Negative 6, negative 10, give me negative 16. Negative 16. I multiply by 2, I got negative 32. Because of the negative, because I'm subtracting, I'm going to have plus 32 with the negative 28. That gives me plus 4. And then 2 by 4 give me 8. And I'm subtracting and I got 0. What was cubed becomes a square. So at the end of the day, I can definitely say that the result of the division of P of x divided by x plus 2 is going to be 5x squared minus 16x plus 4. And because the rest is equal to 0, I can definitively say that from x plus 2, you will be able to define the 0 of p of x. And so when I'm doing this, I'm going to do that on the top. If x plus 2 is going to help you to find a 0, that means I can say x plus 2 equals 0. So x equals negative 2, and negative 2 is a 0 of your function. If I want to find the other 0 of this function, that's pretty simple. I got right here a quadratic expression. If I'm able to define the value of a, the value of b, and the value of c, I will be able to use the quadratic formula, which is x equals minus b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. To avoid to make any mistake, as usual, I'm going to put a plus right here, and now I can say easily that a equals 5, that b equals negative 16, and that c equals 4. All right, so now, if you have to divide a polynomial, and you're not dividing the polynomial by x minus k, but it is in another form, what you need to do, it's exactly the same idea, but now you have to use the long division. So if I want to do the long division, the first thing I want to do is try to define how many times do I have 3x squared inside 3x to the fourth. Well, that's pretty simple. I'm going to have that 3 times x squared. So once I'm able to write this one, I'm going to distribute this 3x squared to the first one and to the second term. When I'm doing this, I'm going to write these numbers, and I'm going to have 3x4, and then I'm going to have minus 15x squared. I forgot a tiny x squared right there. And then I need to subtract. When we are doing the long division, we are subtracting. This is why I decided when I'm doing the synthetic division to keep this in mind and try to always subtract also even in doing the synthetic division. When I'm subtracting, my plus 3x to the 4th becomes negative, and my negative 15x squared becomes plus 15x squared. I'm now able to do my subtraction. I end up to have 12x squared minus 5. I do exactly the same thing. I'm going to have to subtract, and at the end of the day, I end up to have a rest equal to 15. So we can say that the answer of 3x to the 4th minus 3x squared minus 5 divided by 3x squared plus 4 is going to be equal to a 3x squared minus 5, actually. It's 3x squared minus 5 right here. I made a tiny mistake by 3x squared minus 5. Is going to be equal to 3x squared plus 4 plus 15 divided by the rest, so plus the rest divided by 3x squared minus 5. Alright guys, I'm going to let you do the example number 1, the example number 2, example number 3, example number 4, as well as the example number 5. To define, and let's try to do the example number 6 together, and then it will be done for the rest. The rest you will have to do at home. If is x minus 1 a factor of this polynomial? Well, that's pretty easy. You will just have to define and divide and take minus 1 and try to have a 2 to do the synthetic division 2, then a 0 because there is missing x cubed, 3 and negative 5 and 7. You bring down the 2. Then you got a negative 2 right here. You subtracting, so you end up to have a plus 2. So now you got a negative 2. You subtracting, so you got a 5. You got a negative 5. You subtracting, so you got a 0. And then you got a 0 right here. And so now you got a 7. And so do you have does x minus 1 is a factor of this polynomial? No, it's not a factor of this polynomial because the rest is different than 0. Okay? Thank you, and talk to you in class.